Hello. Today we're going to look at factoring a quadratic trinomial of ax squared plus bx plus c, and I'm going to use the box method. I've tried several methods. I haven't tried every method out there, but I have found one that works really well for me and for my students, and so I want to share this with you today. Now, normally box method is a means of multiplying out two binomials. I'm going to make a box right here and show what I mean by that. I'm going to do a very general form though. I'm going to do ax plus b times cx plus d. And then I just multiply by the corresponding boxes. The upper left corner, ax times cx is going to be ac x squared. The upper right box, b times cx, is going to be bcx. The lower left box is going to be ax times d, which is a dx. And then the lower right is b times d, which is bd. I suppose I should put pluses on all these, but I think we understand that these are all pluses. Now, I want to make a few observations about this box here. Observation 1. Notice the upper left. The upper left is the x squared term. That's one observation. The lower right is the constant term. The lower right doesn't have an x. And the other two, others make up, the x term when we add them together. X term when we add them together. Okay, and the fourth observation is a little less obvious, is that if you multiply the two diagonals together, product of diagonals if you multiply the two diagonals together, in both cases we get a b, c, d times x squared. Take a moment and you can see that that is true. You have all the a, b, c, d letters included and you have x squared, except the lower left and upper right, the x's are split up, but then you multiply them together, they're all together. So we're going to take that fact and use that to those four observations. We're going to take those four observations and use that to take a trinomial and it. So I'm going to start with a new screen here, and I'm going to give an example here. I'm going to do 2x squared plus 5x plus 2. And I'm going to make my box down here. And I can tell already two boxes that are going to be filled. The upper left is going to be my x squared term, which is 2x squared. My lower right is going to be my constant, which is the 2. And then the remaining boxes are going to be x terms. We just don't know what those numbers are yet. Well, let's take another of our observations, is that the product of the two diagonals should be the same. Well, if I multiply the diagonal that I know, 2x squared times 2 equals 4x squared. Well, the other diagonal with those missing x terms, those numbers should also multiply to get 4. So if I take factors of 4 and I see which ones, those x terms also must add up to 5 in order to get a 5x. So let's consider factors of 4. We know 2 times 2 equals 4. If I add those, I get 4. Well, that's not the 5 that I need. There's only one other pair of factors of 4, and that is 1 and 4. And if I add those together, I do get 5. And so this is the winning combination right here. So what I'm going to do is I'm going to put those in for those x coefficients. Now I know that 1x is the same as x, but for our purposes here, let's include it so that we can see how this all comes together. Now, we have the things inside the box. The way to get the things outside the box is by taking a row and rows and the columns and getting common factors. Let's first consider the first row, the common factors in both the numbers and in the variables. So the 2x squared and the 4x, their common factor in the numbers, 2 and 4, 2 goes into both of those. They also both each have at least one x, so they have an x in common. Now let's look at the second row, 1x plus 2. Well, the numbers, they don't have any numbers in common. Now anything that they have in common, they will have a 1 in common if they don't have anything else in common. So I'm going to have a plus 1 there. Now let's look at the left column. 2 and 1, their common factor is 1. And they have an x in common. So I'm going to put an x there. Look at the next column, 4x and 2. 4 and 2 have a 2 in common. They don't have any variable in common. So I have 1x plus 2, 2x plus 1. This appears to factor to x plus 2 times 2x plus 1. Now there is an added benefit of using this method for factoring because you can also check your work very easily and quickly. If you're familiar with box method, we can look at the factors here and here and multiply them out using box method and see if what's in the boxes is actually what we would get if we were using box method. So we can have a look and see 1x times 2x equals 2x squared. 1x times 1 is 1x. 2 times 2x is 4x. And 2 times 1 rather is 2. So we can not only do our work, but we can also check our work pretty easily. Now let's do a couple more examples. We're going to try 15x squared plus 2x minus 8. So I'm going to go ahead and make the box down here. Make sure it makes it big enough to fit the numbers that I need. I know the 15x squared is going to go up in the upper left corner rather, and the negative 8 is going to go down here. And I also know that these are going to be something x here and something x here. So I need to multiply 15 by negative 8. You may have noticed from the last time that x squared just basically proves that they multiply the same thing, but really didn't do anything. So really just need to focus on the numbers. 15 times negative 8 is negative 120. Now this has a few more factor pairs to it, and another thing about this is it is negative. What that's going to mean is I'm going to have one positive factor and one negative factor. So let's take, for example, 2 goes into 120 60 times. Well, 2 times 60 equals, move this a little bit, 2 times 60 equals positive 120, not negative 120. So I need one of them to be negative in order to make this multiply to negative 120. Which one do I need to be negative? Well, look at my x value that I've got. It has to be a positive number, which means I need the smaller one to be negative. I add those together, I get 58. That is very, very far from what we're trying to find. We're trying to make it into 2x. So let's say, well, negative 3. Negative 3, or 3 goes into 120 40 times. Those add up to 37. Still pretty far, but we're getting closer. 4 goes in 30 times. That's 26. Getting warmer. There is a decent amount of trial and error to this, but this method takes the trial and error factor to a minimum. -5 goes into 120. Let's see, how many times does that go in? Oh yes, that goes in 24 times. Add those together, I get 19. Okay, obviously we need these factors to be a bit closer. Now, you may have already figured this out, that 10 and 12 are very close together, and those multiply to get -1. And if I make the 10 negative, then I add those together, I get 2. So now we have our winning combination. We have, I'm going to put the 12 up here, and the -10 down here. Now let's look at the first row. 15 and 12, well, 3 goes into both of those, and they both have an x on them. -10 and -8, their common factor is 2. They don't have an x in common. Now there is one more thing to observe, that -10x is right next to the 2 on the outside. If it is a negative, then I'm going to have a -2 there. So that is one thing a little bit different from the previous example. Now let's look at the first column, the left column. 15 and 10. They have a common factor of 5, and they also have an x in common. Now, the 15x squared is positive, so the 5x right above it is also positive. Look at the 12x and the -8. 12 and 8 have a 4 in common. And the 12x next to the 4 is positive, so this is going to be a +4. Now, this took a little bit of process to do. I'm going to scoot this all up a little bit. Okay, this all took a little bit of a process, so let's make sure our answers are right. We can multiply the 5x times the 3x, we get a 15x squared. As we can see here, we multiply 4 times 3x, we get 12x. 5x times -2, we get -10x. 4 times -2, we get -8. And so we see that if I multiply 5x plus 4 times 3x minus 2, I get that trinomial back. So let's try our example. There's one more thing that we need to make sure of, and I'm going to try 8x squared minus 8x minus 6. Now, the reason why I'm doing this one is because there is one more stipulation here. If I were to try and do box method with this particular one, then there might be a problem. Notice that 8x squared, 8x, and -8x and -6, they have a common factor of 2. If that is the case, we need to first factor out any common factors that exist. Otherwise, the box method will lead us in the wrong direction. So we know already that 2 goes into each one of them. 2 goes into 8x squared, 4x squared times. If I multiply those, I'll get 8x squared. -8x. Well, 2 times something, 2 times -4x is -8x. -6, 2 times -3 is -6. So this is the one that I need to be doing the box method stuff on. So I'm going to put 4x squared here. I'm going to put -3 there, something x there, and something x there. So you can tell I'm going to be using 4 times -3, which is -12. I need those factors of -12 to add up to -4. Since 4 is negative, I need the larger one to be a negative number. So let's try -12 and 1. Add those up, that gives us a -11. That's not what we're looking for. -6 and 2. Add those up, I get -4. And that is my winning combination that I'm looking for. So I can put 2 here and -6x there. And I should also point out that it does not matter which number we put in which x spot. It will still work out to the same thing. So our first column, 4x squared and 2x, the numbers have a common factor of 2. They have an x in common. Second row, we have a negative there, so we got a negative, and they have a, looks like they have a negative 3 in common. First column, they have a 2 in common and an x in common again. The second column, we have, looks like we don't have anything in common, so we at least have a 1 in common. And we can double check and make sure that these actually multiply to the things in the boxes, and they do. Now, when we write a final answer, though, we need to make sure, well, first of all, let's write what's in these parentheses, and then let's write what's in the second one. But don't forget this 2 up here, okay? That also carries over down there, and that is our final answer. Well, this video is already getting a little bit lengthy, and I think I have enough examples to show you the basic cases that you're going to be encountering. We'll see you next time.